Next question is how many atoms in cubic close-packed structure and what is its coordination? Before we attempt this question, we see the next question, that is how many atoms are in HCP structure and what is its coordination number. For this question to understand, we shall first see how the HCP structure it is formed. See, in one dimension, the spheres or the constituent particles in a unit cell, they are like this. These are depressions in one layer. In one layer, say it is a layer. These are depressions. Now, if we place second layer, so that the spheres in the second layer, they are placed on the depressions of the first layer. Then a void is created, and that void is called tetrahedral. Tetrahedral void is created if a layer depression is covered by the sphere of B layer, or vice versa. Vice versa means if B layer depression, if there are depression in B layer, they are covered by the spheres of A layer, then also a tetrahedral void is created. And number of tetrahedral void is 2n. If n is the number of atoms, number of spheres in A layer, then 2n will be the number of tetrahedral voids. Means each atom, one atom, it creates 2 tetrahedral voids. Now, if third layer is placed, so that A, B, and this is first layer, this is second layer, and if third layer is placed, so that all the spheres of the third layer, they are aligned with the first layer, so the third layer can also be called A layer, then this will be AB type structure, and this is also called hexagonal close-packed structure. And in this hexagonal closed structure HCP, if we see some example of this, then magnesium and zinc are the example of HCP, and its coordination number is 12. Cn is 12, and its packing efficiency is 74%, means only 26% is empty space in the unit cells. And Now we come to the structure of cubic closepacked structure. Cubic closepacked structure. See, in SCP we saw that there is AB type structure. But what happens if the tetrahedral void of first layer is covered by the tetrahedral void of second layer? A का tetrahedral void और B का tetrahedral void, they are over one another. Then what happens? Tetrahedral void of A is covered by tetrahedral void of B. Then what happens? Octahedral void is created. And then if third layer is placed and that will cover octahedral void, then that will not align with any of the previous two layers. That will not align with the layer A or with the B. So that will form another layer that will be called C. And the spheres, atoms in the C layer, they will cover the octahedral void created by these two layers. Now the fourth layer that will align when the spheres of the fourth layer, they cover these octahedral void. What happens? Fourth layer will align with first layer. Then we see that this is ABC structure, ABC type structure, and this is called cubic close packed structure or FCC, face centered cubic or FCC, cubic close. And we have learned that in FCC, how many atoms were there? In FCC, there were 4 atoms, and coordination number of FCC or cubic close packed structure is 12. Coordination number is 12. So now we come to packing efficiency. What is the packing efficiency? Packing efficiency is the, let me first, this is the example of magnesium and zinc are the examples of HCP structure, and in cubic close packed structure, this is examples are copper and silver. These are the examples of cubic close packed structure. Now we come on to the next question, that is, what is packing efficiency? Packing efficiency can be defined as the space occupied, volume occupied by constituent particles or atoms divided by volume of unit cell multiplied by 100. This is in percentage. So the more volume is occupied by the atoms, the less will be the empty space and more will be the packing efficiency of the unit cell. Now we come on to these, what is the packing efficiency of simple cubic lattice? There, that is 52.4%. And what is the packing efficiency of body centered cubic? That is 68.04%. And cubic close packing 74%, 74% FCP, and FCC also 74. See, these FCP and FCC, they are both one and the same thing, and their efficiency being 74%. So these three are most efficient in packing efficiency. Now we come on to some numericals. Let us see this. What is this question? The cubic close packing, the number of tetrahedral and octahedral. So octahedral is the number of atoms, that is n, and tetrahedral, each atom creates two tetrahedral words, so that is 2n. If number of atom is n, then tetrahedral words will be 2n. Now we do some numericals. This is numerical number 1. A compound is formed by two elements. A compound is formed by two elements. One is X and another is Y. The element Y forms CCP. So the number of atoms of Y will be n, and X occupy 2 by 3 of tetrahedral words. Tetrahedral words will be 2n, and number of atoms of X will be 2n into 2 by 3, that is 4 by 3 n. So X is 4 by 3n and Y is n. Then if we bring 3 here, then this will be 3n and this will be 4n. So the formula will be x4 y3. x4 y3 will be the formula of the compound. Now we come on to the other question. An oxide of aluminium is crystallized where oxide ions occupy SCP, means oxide ions are number of oxide ions are n, and aluminium occupy 2 by 3 of octahedral. Octahedral is also octahedral words. Number of octahedral words are n, and 2 by 3 n will be the number of aluminium ions. Then 2 by 3 aluminium and oxygen will be n. Then oxygen, if we bring here, then 3n and 2n, Al2O3 will be the formula of the oxide of the aluminum. So this finishes our video, and in next video we shall do some more questions, practical questions and numericals. Thank you for watching the video.